Okay, so hello and welcome. Thank you for joining me on this investment management vignette on calculating returns. Okay, so the formula for calculating returns over an entire period is the future value less the present value, that's the value today, the future value, the value that it grows into. We subtract those two, the difference, so it's the future value less the present value, and we divide it by the present value. And then we multiply our result by 100 over 1 to get us a percent. And so in a simplified way of writing it, return equals FV less PV divided by PV times 100, or P2 less P1 over P1 times 100. Now these are three ways that I will describe this equation in this unit. I'll either describe it as future value less present value divided by present value, FV less PV over PV, or P2 less P1 over P1. They all mean the same thing, but they will be used interchangeably throughout the unit. Okay, but, and there's always a but, isn't there? It's impossible to compare returns over different periods using that method, and in investment management, we want to be able to measure returns over a defined period. And so we need to compare like with like, and we need to convert a return from a period, an open period, into an annualized return, and that's what we're doing. That's what we're learning about today. But annualizing returns is complex. That's why it's taught at university, not taught at high school. Because there are three different types of returns. Now, I will be very clear in defining the type of return that we're looking for throughout the unit. So it'll be clear, but you just need to know which formula you need to apply. And which formula is based on the interest type and the interest period. Okay, so what are the three types of returns? Well, there's simple interest. And simple interest is interest on your principal only. And that is used in the short-term money market, that approach. We have compound interest, and that is where you have interest on your principal and interest. So when you put money in the bank, you earn interest on your principal, but if you keep your money in there when they pay the interest, you'll also earn money on the principal plus any interest you've earned. And this approach is used in all other markets other than the short-term money market. And we have continuously compounded, which is also a form of interest on your principal and interest. But the interest period is very, very short. It's actually less than a second. And it is used in the derivative markets. So compound interest is used in all markets other than the short-term money market and really the derivative market. Continuously compounded is used in the derivative market, and simple interest is used in the short-term money market. And in this unit, you'll need to know all three, although we will focus on simple and compound interest. There's just only one or two questions about continuously compound in the mid-semester. I really don't ask it in the final. Okay, so simple interest. Okay. What we're going to do is we're going to break down the overall return throughout the whole period to a return per n interest periods. This is the equation. I've actually got three forms of the equation on the one line, so there's no need to panic. So the return equals 1 on n times future value less present value divided by present value. That also equals 1 on n times FV less PV over PV, which also equals 1 on n times P2 less P1 over P1. And of course, as I said, I will use these approaches interchangeably throughout the unit. They all mean the same thing. They're all picking up the same numbers, all exactly the same approach. It's just that I'm referring to it in slightly different ways depending upon the situation. and n equals the number of interest periods. Okay, so we'll do an example, shan't we? What is the simple interest rate of return required to turn $200 into $300 over 5.2 years? So what are the variables we got? Well, PV, the present value, is $200. FV, the future value that we're turning the $200 into, is $300. N equals 5.2 years, 5.2 interest periods. And therefore we want to find R to be able to do this. So we go to our formula, return R equals 1 on N times FV less PV divided by PV. We put the numbers in, return equals 1 over 5.2 times 300 less 200 over 200. And we end up with a return of 0.0962, which when we convert it to a percentage, which is multiplying by 100%, gives us 9.62%. Now, if you're having difficulties with this concept, no need to worry. That's why we're all here. Just repeat. Just turn the recording back a couple of minutes and just repeat this process. Or just pause it here and just practice it on your calculator until you can get it right. Looking at simple interest again, instead of just calculating returns, we're now going to calculate the future value of something having a simple interest return. And that equation is future value equals present value times 1 plus return times n, which can also be written as PV times 1 plus R times n, where n is the number of interest periods and R equals the simple interest return or the interest rate. Both terms are interchangeable. Let's do an example. What is the future value of $375.69 invested at 8.75% simple interest? There's the giveaway, over 7 years and 4 months. Now, I've deliberately chosen this question because students are challenged by this one. What students have been taught throughout their academic career is look at the question, don't read it through, look, madly search for numbers, find the numbers that you want, shove them into your calculator. Now, my classes are a little bit different. I actually want you to think about what's going on. So I'm likely to ask you a question like this, but you need to think. You can't just shove all the numbers here into a calculator because you get the wrong answer. So let's work our way through. What have we got here? Why would I say that? Well, let's work our way through here. The present value equals $375.69. R equals 8.75%, which when we divide it by 100 is 0.0875. In other words, we've taken a percent and turned it into a decimal. And here's the tricky bit, which always gets students confused. N equals 7 plus, well, remember there are 12 months in the year, 4 over 12, which is 7.3, repeat up, 7.3333. And the objective of this question is to find the future value. So the future value equals the present value times 1 plus R times N. We substitute in the variables. FV equals $375.69 times 1 plus 0.0875 times 7.3333. And we get 616.7567. Now, if you answered that in the exam, you would be marked wrong. In fact, in the mid-semester, I would give you an answer like that, and that would be the wrong answer. And you would be saying, but that's the answer which I have on my calculator. And then you'd be sending me emails telling me about how you got the right answer. But of course, the Australian currency is dollars and cents. There are 100 cents in the dollar. There's not 10,000 cents in the dollar. There's only 100 cents in the dollar. And so we have to round that second decimal point. So therefore, the answer is $616.76. And that would be the correct answer. Now, in a simple exam like the mid-semester, I would give you both of those. Option A would be 616.7567 and option B would be 616.76. And that's deliberately so that students are thinking. If you're not thinking, you'll look at your calculator, circle the number which you see. If you are thinking, you'll go, hold on there. I remember something about this. Yes. 2 decimal places when we're talking about currencies. A value of something, so it's 616 and 76. That would be the correct answer. The other one is wrong. Now, students might think that I'm being unfair by taking that approach. But when you think about it, in the financial markets, we're dealing with millions of dollars. And if you're out just by a small fraction on millions of dollars that are traded lots throughout the day, there are hundreds of thousands of transactions throughout the day, the numbers start adding up very, very quickly. And so to make sure that everyone is being treated fairly, we are very precise in our numbers and our calculations. So I implore for students to be the same. Okay, calculating the present value using simple interest. And funnily enough, we will be using this equation a lot. The present value equals the future value divided by 1 plus return times n, which equals, another way of writing it, FV over 1 plus R times n. N is the number of interest periods, R equals the interest rate. So here's an example. What is the present value of $1,245,987.32, where the simple interest rate is 2.68% and the term is 289 days? FV equals $1,245,987.32. Excuse me, R equals 2.68%, which equals 0.0268. And N equals 289 divided by 365. Just for simplistic sake, we assume it's 365 days in the year, even though there are leap years, okay, every 4 years. And that comes out to be 0.79178082 years. And so what we're asked to find is the present value. We put that into our calculator. Present value equals FV over 1 plus R times N. And we get present value equals 1.1245987.32 divided by 1 plus 0.0268 times 0.79178082. When we calculate it out, rounded to 2 decimal places, we get $1,220,097.19. Now, if you have a different number to me, go back and have another go. Make sure you're rounding numbers to the right number of decimal places. Compounding. Now that was simple interest. We're now looking at compound interest. Calculating out the compound rate of return. No, it's not that complicated. I've just written it out here 3 different ways. They're all the same equation and they're all looking at the same variables. Return equals future value divided by present value raised to the power of 1 on n less 1 times 100% to turn it into a percent, which also equals FV over PV to the power of 1 on n less 1, all to the power of 100%, or P2 divided by P1 raised to the power of 1 on n less 1 times 100%. They're all the same equation. They're just 3 different ways of describing it. We'll use these 3 ways interchangeably throughout the unit. An example, what compound rate of return is required to turn $25 million into $175 million over 22 years? Now, this is a real type question. This is the type of question that governments are asked to do all the time. This sort of a question is for a sovereign wealth fund, like the Future Fund. So the present value equals 25 million. Future value equals 175 million. N equals 22. What is R? Write out the equation. Return equals FV over PV to the power of 1 on N less 1 times 100%. Substituting the variables. 175 million divided by 25 million to the power of 1 on 22 less 1. And we get 0.09248013, which when we multiply by 100 and only reduce the return numbers down to 2 decimal places, we get a return of 9.25%. As well as calculating out the rate of return, we can also calculate out the future value. So the future value equals the present value times 1 plus R to the power of N, which also equals PV times 1 plus R to the power of N. So let's have a look at an example. What is the future value of $875,882.69 invested at 8.65% per annum compound over 5 years and 2 months? Again, there's a trick here. Remember, 5 years, 2 months. It's 5 plus 2/12. FV equals 875,882.69. R equals 0.0865. N equals 5.16 repeater, which I've rounded here to 5.1667. We write out the equation. Future value equals the present value times 1 plus R raised to the power of N. We substitute in the variables. 875,882.69 times 1 plus 0.0865 raised to the power of 5.1667. And that will get us 1,344,623.67. So over 5 years and 2 months, we're able to grow 875,882.69 into $1.3 million at the rate of 8.65%. Okay, as well as calculating out the future value and the return, we can also calculate out the present value using compound returns. And the present value equals the future value over 1 plus return raised to the power of N, which is FV over 1 plus R to the N. Both are the same equation. So let's do an example. How much is required to be invested today at 7.45% per annum over 15 years to have $4.3 million? Well, future value is $4,300,000. R equals 0.0745. N equals 15. And so what is the present value? We write out the equation. Present value equals FV over 1 plus R to the N. We substitute in the variables. $4,300,000 divided by 1 plus 0.0745 raised to the power of 15. And when we calculate that out, we get $1,463,430.69. If you're having difficulties with this, go back and have another go. And now we're going to look at our third form of compounding, which is continuous compounding. With continuous compounding, the compounding period is infinitesimally small, less than a second. We slice up that timeline very, very fine. So calculating the future value using continuously compound returns, because future value equals PV times E to the power of R times T. Now, if you don't know where E is on your calculator or you're unsure, how to calculate numbers where you're raising e to a power, go and have a look at my vignette on calculator basics, because we covered there. Let's do an example. Calculate the future value of 750,000 invested at 722% per annum over 5 years using continuously compounded returns. PV equals 750,000, R equals 0.0722, which is dividing it by 100, of course. N equals 5, and you're left with what is FV? Well, write out the equation. Future value equals present value times E to the power of R times T. Future value therefore equals 750,000 times E to the 0.0722 times 5, which equals $1,076,072.60. Now we can also calculate out the present value using continuously compounded returns. PV equals FV over E to the raised to the power of RT. Now, the interesting thing is if you raise a number to a power, and that number that you're raising to a power is the denominator, in other words, you're dividing a number by a number raised to the power of something. Another way of writing it is to put a negative inside of the negative power. So future value divided by E to the RT is the same as future value times E raised to the power of minus RT. Those two are the same equation. Now, the second form of the equation is probably a little bit easier to enter into your calculator. So have a think about doing that. So let's do an example. Calculate the amount needed to be invested at 4.69% per annum continuously compounded over 11 years to end up with $1,664,212. So we know what the future value is, 1,664,212. N equals 11. R equals 0.0469. And all we have to find now is the present value. And if we write out the equation, present value equals the future value over E raised to the power of RT, which also equals FV times E to the minus RT. And I actually have written out both forms of the equation, and I calculate both forms of the equation just to prove to you that the two are the same. And lo and behold, they are. The present value is $993,473.13. It's the same answer no matter which way you calculate. Okay. Calculating the return R using continuously compounded returns. This is the last form of the three forms of compounding that we're looking at, of three forms of return calculations that we're looking at tonight. R equals 1 over T times ln, which is the natural log, times FV over PV. Now, if you're unsure as to where to find ln on your calculator, I recommend that you go back and have a look at that vignette on calculator basics. I run through how to use that functionality on your calculator in there. So let's do an example. Calculate the continuously compounded return required to turn 172,856 into 198,444 over 3 years and 27 days. PV, 172,856. FV, 198,444. T equals N, which equals 3 plus 27 over 365, because it's 27 days, which equals 3.07397,260. My preference when we're working with these sorts of numbers is to work in 8 decimal places. Sometimes 4 is okay, but often I prefer 8. And what is R? Oh, we shove it all into our equation, don't we? R equals 1 on T times ln FV over PV. Substituting the variables, and we get R equals 4.49%. So if you've had any difficulties with any of these, I would recommend that you go back and replay the recording. It's there for that purpose, so that students can practice these equations to make sure they understand them. That won't be so much easier when it comes to the tutorials. Okay, so what have we learned? Okay, we learned that how to calculate the return over a period. We've learned that there are 3 types of returns. Now, simple interest, compound interest, and continuously compound interest. Well, I hope that you've enjoyed this vignette. I hope you found it useful. I look forward to seeing you in class.